Okay, so we need to find the antiderivative of this. So this is really the same as this. It's just a different way of writing it. Okay, so we need a guy in here. We need a function. Okay, we need a function. Let's call it f. That's equal to this. Such that when we take the derivative of f, we end up with 1 over 3x plus 1 to the fifth. So this, another way of thinking about this would be to write it like this. Okay. Now, what can we do? Well, we can guess at this a little bit. So we know that if we just had this, whoops, this should be a -5. Sorry, there we go. We know that if we just had something like this, that the antiderivative would be to add 1 to this and divide it by that guy, and then add our constant of integration. So this would give us -1 over 4 x to the fourth. Okay, plus our constant. Now, here's what we're going to do. Let's take a look at this, okay? And let's say that this inside here was no longer x. It was 3x plus 1, okay? So now, let's just replace this like that. And let's look at differentiating this. So this is really this. And so when we take the derivative of this, the derivative of this guy is 0. So the derivative of this guy is -4 times a fourth times 3x plus 1 to the -5th. But then we have to multiply it by the derivative of the inside. So what happens here? Well, the derivative is 3 times what we want. So what I'm going to do is I'm going to divide this by 3. And so if I do that, if instead of using this guy right here, okay, let me erase this now so we have some room. Instead of using that guy, let's use this guy. And now this was the same as this, but instead, since we're going to get 3 times as much, let's divide this thing by 3. So we'll go like this. Okay, so this would be -1/12, 3x plus 1 to the -4th plus c. Now let's take the derivative of this and see what happens. So let's call this guy large f. Okay, so now if we take the derivative of large f, okay, we get -1/12 times -4. Bring this guy down. Okay, we're going to subtract 1 off the power. Then we're going to multiply it by, so chain rule, multiply it by the derivative of the inside, this, plus our constant. So this is going to give us positive 4 over 12 is 1/3 times 3 times 3x plus 1 to the -5 plus, now the derivative, I should have mentioned this just a second ago, but the derivative of this guy is 0, so I forgot to take the derivative of that. So we get this right here, and that's equal to just 3x plus 1 to the -5th, which is 1 over 3x plus 1 to the 5th. So what it looks like is this, the integral of this, it should be equal to this guy right here, which would be -1/12 3x plus 1 to the negative 4 plus c, just like that. Okay. Now another way of doing this, okay, it's really important that you can work through and think about, well, what would we have to plug in there to get the antiderivative, right? And so we play around with the functions a little bit. And one of the tricks that we can use is we can replace this guy in here with something else. Let's call it u. So let's let u be equal to 3x plus 1. So then this right here becomes the integral of u to the negative fifth dx. Well, I'd like to replace dx with du because I've got a u here. So I'm going to make a substitution or a change of variables, okay? So du, now this right here is going to come from our differentials. So du is equal to the derivative of this guy times the change of x times dx. So I'm going to replace dx with du over 3. So this will be the integral of u to the negative fifth du times a third. And now the integral of this is going to be u. We add 1 like this. And this is going to be u to the negative fourth over negative 12 plus c, which is equal to u was 3x plus 1. So this will be 3x plus 1 to the negative fourth over negative 12 plus c, which is negative 1/12. And we can bring this guy down to the bottom too if we want to. Let's put this guy, let's center this guy. Just like that. And we get the exact same thing that we got before. So what we're doing here is making a substitution. But remember, this can't be done until this variable matches this variable right here.